on the x-axis, we're going to go 4 to the left and 4 to the right. And then, like I said, we're going to go through those 6 steps. Are we ready? Yes, no, and so? Alright, step number 1. In order to tell me in behavior, you have to know what that first number was going to be. But hopefully you learned through the homework on Tuesday that redistributing those parentheses suck, right? Okay, so you don't really want to do that here. That's way more work than you want. So what we're going to do is we are going to do what I call tracking the lead. In other words, I'm only looking at that first x as I go through. So if I had an x minus 1 squared, then the highest x that I would have would be the x times the x. So I would get an x squared off of this parenthesis. Again, I don't care what everything else comes out to. All I care about is that first x would be an x squared. Good so far? I then would take that x squared and I would multiply it with this x right here, and that would give me x cubed in the front. And then I would take that x cubed and I'd multiply by the 2, and that would give me a 2x cubed in the front. Again, I don't care what comes after it because that does not affect the end behavior. All that affects the end behavior is the front. Everybody see how I got that? Because like I said, this is more like what you'll see tomorrow, and I do not want you refoiling those out. That would be a waste of your time. Are we good? All right, so from here, what is my degree? 3. That is an odd number. So my ends, what do I know about my ends if it's odd? They go opposite. My A value is 2, that's positive. So what do I know? I think I heard it. Kind of hard to tell for the drums. If it's positive, what do I know happens with my graph?
It's sloping up.
It slopes up. Good. So in essence, my picture kind of looks like that, right? So on my graph, how I'm going to mark that is just really lightly, because you'll probably have to move the location. But I'm just going to do an up arrow over here and a down arrow over there. Again, really lightly. You're probably going to have to move them depending on where everything lands. But that helps me with the first part of my picture here. Good so far? Questions so far? All right, number 2 is going to be the y-intercept. As always, we plug zeros in for x to get those. So 2 times 0 plus 2 times 0 minus 1 squared. 0 plus 2 is just 2. 0 minus 1 is negative 1. If I square that, I get 1. 2 times 2 times 1 gives me 4, which means I cross the y-axis at 0 to 4. So I'm going to plot that. Are we good so far? Like I said, this should all be like, oh yeah, I got this. We've been doing this for a while, right? Number 3. X-intercepts, I'm not going to lie on these, or it's going to be where your most heaviest work is going to happen in. Same with quadratics though, right? That's where your heaviest work was happening in. That's where we set everything equal to 0. But again, for this particular problem, it's already factored for you because I have those parentheses there. So all I have to do is set them equal to 0 and solve. Means I cross at -2 and at 1. So I'm going to come down and plot -2 and 1. Are we still good? So now my next part is the new part. My next part is, do you cross there, or do you just simply touch it, turn around, and come the other way? And again, that goes on my multiplicity. So if I'm looking for step number 4, I'm looking for, does it cross or touch? And that's based on the multiplicity. what is the multiplicity of the negative 2? In other words, how many times technically do I get negative 2 from this? Yeah, I only have one parenthesis there, right? So I only get it once. So that multiplicity is a 1. 1 is odd. So we're going to cross at negative 2. Again, if I'm looking at the 1, technically, how many times would you have gotten 1? Here. 2. Why 2? Yeah, because I have 2 parentheses with them, right? I have this exponent here telling me I got that twice. So my multiplicity on the 1 is twice. I have that number twice. 2 is an even number, so we are just going to touch 2. That's the new part. Yeah.
Could multiplicity be a degree? Is that what you're trying to get at?
Multiplicity is related to the degree, yes, but it's not it's the highest exponent of that parenthesis. So if I'm looking at the parenthesis, that parenthesis has an exponent, right?
Yeah.
That's my multiplicity.
Okay.
If you don't see an exponent,
that's just
you only
one.
got it once.
Yeah. Okay.
Yeah. So like I said, it is like a degree, but it's not exactly what a degree is.
Will the exponent be anything higher than 2?
Yeah, it could be. So if it's a 3, 3 is odd,
Like
a
a
cross.
Yeah.
Okay. All right, so if I'm looking, I need to put this together with my picture. If I'm coming to the negative 2, right? Negative 2, we say we cross there. Well, I have an arrow down here. Does that make sense? So if I have to cross, I have to cross from the bottom up. Does that make sense? Because like I said, otherwise I can't get to my arrow. Now I'm up here somewhere, I'm doing some sort of craziness right here, but then I have to come back down to get to the 1. But at 1, we just touch it, which means I have to come back down, touch it, turn around, and go back up, which should make sense because I have to touch my arrow also. Does that make sense on how I took that and put it on my graph? Any questions with how I took that and put it on my graph? So I have the arrow pointing down, right? So in order to connect with the arrow pointing down, if I'm crossing, I'd have to cross like that. In other words, if I cross like that, I'm going in the wrong direction to get to my arrow.
Okay.
If I go like this, now I can get down to my arrow. Likewise, if I'm up here, because I crossed like this, right? So now I'm up here. If I'm up here, I have to come down to hit my 1, but I just touch it and come back down.
So we kind of do like a U-turn for the touch?
Yeah, you do a U-turn for the touch. I like that. Yeah. All right. Questions there before we do 5? Step number 5 is really a check on my graph. It tells me if I need to make my table super huge. Maximum amount of terms is always the degree minus 1. So what's my degree of this? 3. Minus 1 means how many maximum terms do I have?
2.
I got 2 terms max. So let's see if I can see them. If I'm coming like this, right, I have to kind of turn around to hit this y-intercept. So that's 1 turn. Then I have to come, I'm turning here, that's 2 turns. I have all 2 turns. I can't turn again, right? I can't come up here and turn again. That won't work. That's too many turns. Does that make sense? Yeah.
So the only turn, it would be a straight line from your arrow to
From my arrow up, yep.
Okay.
So that's what I'm going to get to. So because of that, that means that this here goes in a straight line to get down to my arrow. That's why I said you might have to bring your arrow over a little bit. Likewise over here, I'd have to go to basically a straight line to get to my arrow on this side. Good so far?
Yeah.
Which means the only place that I don't know is this place right here. Because I don't know how far up I go. In other words, I could just go as high as the y-intercept and come back. Or I could sort of skyrocket and then come back down. I don't know. So in order to do step number 6, I'm out of work here, so I'm just putting it on the side. There's only one place that I'm curious about, and that is when I get to -1, is that gonna be above my y-intercept or below it, so that I can make my y-intercept that term? So I'm gonna plug in -1. Does that make sense on that selection? All right, so if I do that selection, I'm coming through to my original equation and I'm just plugging in a -1. Again, I'm gonna do this up here since I'm out of board. On your notes, you should probably do it underneath to be neat. So I have -1 plus 2 times -1 minus 1 squared. -1 plus 2 gives me just 1. -1 minus 1 is -2. Squared is 4. 2 times 4 gives me a value of 8. Which means when I'm at -1, I'm all the way up here at 8. So when I connect, I have to come up, hit that point, turn around, come back down. And now I have my graph for that function. Does that make sense?
So when like you're trying to figure that out, you pick the number that's in between your.
Yeah, it's
X
you pick the
value.
number that's in between the points that you're not sure about.
Okay.
All right, so again, I'm gonna erase this just because I'm out of room, and then you can go under, keep going underneath yours. Question?
Where'd you get that point, like right there? The
This
peak.
point?
Yeah, that peak. Yeah, that point
Is
right
the
there.
point that I found when I plugged in -1. So I took
Okay.
-1, plugged it in,
Okay.
simplified it,
Right.
got 8. So you plot -1, 8.
Okay. And then you just sort of connected them.
And then I connected it, yeah.
Okay.
All righty.
Wait. Did you just find the -1? It was in between the.
It was in between, it was the only part I didn't know what was happening in. In other words, here, I know I had to dip here and come up, right? Here, I knew I had to connect here, but I didn't know how far up to go here. In other words, I could have just stopped here, that would have been wrong though, right? But I didn't know if I had to go higher, so I picked the point in between to see if I had to go higher.
So where did you get the point on the y-axis?
The y-intercept, the work we did for step 2, that I just erased.
Where you plugged in,
I plugged in 0.
when you plugged in 0, okay. It's right here.
Okay.
I have it, yeah.
Good questions. Are there any others before we continue with this one to wrap it up? All right, so again, just continue down your paper, but I had to erase since I'm out of board. There's an idea of what we call a local minimum. Local minimums are any places where you hit a dip. So in my graph, when I'm looking, I have a dip right here. Does that make sense? That ordered pair is what?
1, 0.
So my local minimum is at 1, 0. You also have what we call local maximums. The local maximums go the other way. They're the ones that have the peaks happening. That only happens one spot, that happens right here. So where is my local maximum?
-1, 8.
Questions? All right. The next one we're going to do, we are going to have a graph already graphed for us, and then we're going to pull some vocabulary from that, because sometimes on your quizzes you'll be given graphs, and then you'll be asked to pull something like the mins and maxes and such. Like I said, we might not be able to finish all of it, and if not, that's fine. We'll finish it tomorrow. It won't take us very long. So problem number 2. We're going to end up graphing the graph out. So I want you to do your x and y axis. On the y axis, I want you to go 4 up and 4 down. And on the x axis, I want you to go 7 to the right 7 to the left. Once you have that, are we ready to plot? I'm going to start giving you points to plot. All right, so plot the point -7, -1. I think that went a little bit lower than it should have. -7, -1. -5, -3. Keep going crooked. -3, 0. -2, 2. 0, 0. 1, -1. 3, -1. Bless you.
Bless you.
And then 4, 1. And starting with our left point, we're just going to connect our dots. So I'm going to turn, you do flatten, and then I go over. And on the right hand side, we're going to put an arrow. Where are my x-intercepts here?
-3, 0.
Is that the only one?
0, 0.
Are those the only two? Yeah, there's another one, right? But you kind of have to guesstimate it.
3.5?
Yeah, so this one right here, that's what I would say. It looks like 3.5 or 3.5, so that would be my last one. Sometimes you have to guesstimate them. It's not the perfect solution, but it's all you got. Where do I cross the y-axis? 0, 0. In fact, if 0, 0 is an x-intercept, it will also be the y-intercept. You will only get one y-intercept, otherwise it's not a function. Local min.
-5, -3.
Good. Everybody sees where she puts that? Local max.
-2, +2.
Couple of things to make note of. If you have a point that stops, it is not a local min or local max. Okay? If you have a point that flattens at this level, it is not a local min or local max because it flattens. In other words, this is not one of those little dips. I don't have an absolutely smallest point in that slot. Okay? So that would not be one either. Make sense? The other names for these, instead of saying local, they can say relative. Relative min and relative max. All right. We've already done domain and ranges before, so this should be a review, right? So if I'm doing the domain, what x values are possible here? What's my domain here? Yeah.
All right, numbers.
It is not all real numbers because my graph stops. Larger than a -7. So I started at -7 and I went on forever, right? So my